Hello, and welcome to the Grain Farmers of Ontario Grain Talk webinar featuring the spring weather forecast and how weather patterns can affect weather that we receive here in Ontario. I'm Laura Ferrier, an agronomist with Grain Farmers of Ontario, and joining me today from GFO is Marty Vermey, Senior Agronomist, and Mike Buttonham, Sustainability Specialist. Our guest of honor for this spring forecast is Brett Anderson. Brett is a senior meteorologist at ACCUWEATHER Inc., which is located in State College, Pennsylvania. Brett grew up in Rhode Island and wanted to be a meteorologist since the age of 7, having a strong interest in big storms, especially snow. He graduated from Rutgers University with a degree in atmospheric science and soon after started his career at AccuWeather in the summer of 1989. He is currently in his 33rd year at AccuWeather. Brett creates most of the Canadian and US weather graphics that are displayed online and for TV. In addition, he has been writing the AccuWeather Climate Change and Canada weather blogs for at least 12 years now. He is responsible for the seasonal forecasts that are provided for Canada and from time to time also broadcasts weather forecasts for radios in the US. Brett and his wife Cheryl have been married for 31 years and have 3 children. Now, Ontario's farmers may not hold degrees on atmospheric science, but weather is something that we are constantly paying attention to throughout the year, sometimes praying for rain to arrive and other times for it to stop. And I think that Brett will be able to give us a good outlook on which way things might go this spring. Brett, I'm so excited to hear what you have to share with us today, and welcome to our webinar.
Thank you for having me. It's a pleasure to be here. I'm going to talk about several things in this session here. We have to first, before we talk about the future, we have to talk about the past and what's been going on. I'm also going to talk about a little bit about El Nino and La Nina. You guys mentioned that. You want me to bring that up a bit. And then, of course, we'll get to the outlooks for the spring across Canada and also the U.S. We also do forecasts for the United States. I'm not in charge of the United States forecast, so I am presenting some of the information that one of our other forecasters recently released on that. Our Canada forecast was actually released yesterday, so brand new here. So getting a fresh forecast. So we're going to start out here. Presentation summary again. We're going to talk briefly about the observed climate trends across Canada. Pretty much going back 70 years or so. That's when Driving Canada has most of their data going back to the late 1940s. I'm going to look at what's been going on with observed data there, temperatures and precipitation. And then we'll take a crack at what the future may hold in terms of climate projections over the next 10 to 30 years. And I'll try to talk a bit about, mostly about Ontario there. And as I said, El Nino, La Nina, been on that. Analogs, those are used quite often when we come up with these long-range seasonal forecasts. What we do is with an analog, we look back at the weather this past winter, fall, and try to match it up with other years, similar, patterns going back as much as 50 years or so. And then when we see a match, we kind of, okay, let's take that year out and keep, finding years that match up. And then we come up with analog years, and then we average those out and to come up with a projection for, let's say, spring or so. So we use analogs, and then, of course, we use computer data, computer forecasts, and, of course, observed data to kind of blend all together and come up with a seasonal forecast. And, of course, seasonal forecasts have their strengths and weaknesses, but there, of course, is a strong demand for that, obviously. So start out looking at climate trends over the past 70 years across Canada. And again, I'll talk mostly about Ontario, but biggest changes we've seen since the late 1940s has been across northwestern Canada. And all that brown there, that's an increase in anywhere from 4 to 5 degrees Celsius since the late 1940s. Very significant across northwestern Canada. Less so as you get into the southeast, only about half a degree up to around 1.5 degrees or so during the winter. Now, spring, the pattern looks similar. Northwest has been the greatest warming, but the changes are not as great in the spring. As we get ahead to the summer, summer has seen the least amount of temperature change across southern Ontario. And then you get over to the autumn. The north, far north, really sticks out. The reason for that really is the loss of sea ice in the far north. With less sea ice in the late autumn, developing later and later in the autumn, you have a lot more open water up there, and thus open water is darker it absorbs much more of the sun's energy, and therefore it just doesn't cool off as quickly as it normally should when there is building ice. At least reflects a lot more of the sun's energy. So that is not really surprising, seeing that in the autumn in the far north. So breaking it down by province, we've in Ontario at least, we've seen an increase of about 1.3 degrees Celsius annually since the late 1940s. The greatest change in the winter, least amount change summer and autumn. And there again, go down the bottom of the chart, you can see northern Canada almost twice as much warming, especially during the winter compared to some of the other places. So that's the changes that we've seen since the late 1940s. And actually, these numbers might be a little bit higher because you can see that data goes out to 2016. That's the latest we have for this period. So wouldn't be surprised that some of these numbers are about a 10th degree warmer than what we're seeing. Growing season trend. Since the late 1940s, red means more increase in growing season days. Blue means a decrease, and hard to find any blues on that map, but we see one little tiny blue in Saskatchewan there, and I actually was questioning why that's there, but the reds clearly outnumber any blues, and you can see the greatest amount of increase in length of growing season has been out across southern British Columbia, southern Alberta, with an increase anywhere from 20 to 35 days. And then also another peak out across Atlantic Canada, less so from the southern prairies into Ontario, but still anywhere from probably 10 to 20 day increase in growing season since the late 1940s. Rainfall trends, and this includes snowfall as well, precipitation since the late 1940s. Again, this does not go out all the way to 2021, but it's close enough, gives you a pretty good idea. We've seen the greatest increase across far northern Canada. The reason being that region typically very dry. It's almost like a desert. So any increase in moisture there, you're going to see a higher percentage, more quick uptick in the percentage increase up in those areas. Whereas in southern Canada, where especially eastern Canada and southwestern Canada, it's typically see a fair amount of moisture in a given year. So the increases are not quite as great. And you can see in Ontario, we've seen generally about a 10 to 20% increase in precipitation since the late 1940s in southern Ontario and eastern Ontario, but less so in parts of northern Ontario. And then again, northwestern Ontario, you see another increase there. And overall in Canada, you can see the chart on the right that shows a steady increase in precipitation. Excuse me, I have to drink, dealing with the cold. It's its greatest increase pretty much since late early 1980s with the rainfall and snow. Bringing it down by season, really winter sticks out like a sore thumb compared to all the other seasons here. You can see drier conditions showing up across much of Western Canada during the winter, and the drier trend since the late 1940s. North, pretty much all seasons have turned wetter. And then in Eastern Canada, and then we can focus on Ontario, winter in Southern Ontario has been trending a little bit wetter. Northwestern Ontario, slightly drier. And then it's again spring, wetter in Northwestern Ontario, Southern Ontario slightly wetter. Same deal pretty much in summer and also in the fall. So clearly much of Canada has been turning wetter each season. Again, the exception pretty much the winter. And again, down by province, we can see Ontario about a 10% increase in annual precipitation since the late 1940s, with the greatest increase during the autumn and spring. So looking to the future, we've looked at the past a little bit. Now let's jump to the future. Well, how do we come up with some of these future projections? Well, we have to look at greenhouse gas emission scenarios. Clearly, the world is warming, and much of that warming is due to an increase in greenhouse gas emissions. So we're going to look at some of these scenarios that the International Panel on Climate Change has developed, RCP 2.6, RCP 8.5, and we're going to focus on those two. The best scenario, which is the green, the worst case scenario, which is the red. Somewhere we're going to end up probably by the end of the century, somewhere in between, I suspect, somewhere between the 6 and the 4.5. But what I'm going to be showing you is the two extreme case scenarios with the projections here in terms of rain and temperatures. So quickly, future average summer temperature projections. I'm going to focus on the summer. So that's clearly when we're seeing most of our growing, of course. Again, and you were asking me to focus pretty much on the next 10 to 30 years. So that's what I'm going to focus on here. So in the best case scenario, RCP 2.6 on the top left there, the next 10 to 30 years or so, projections say we'll see an additional 1.5 to 2 degrees Celsius increase in temperature across southern Ontario, also eastern Ontario, a little bit less so across northwestern Ontario. And then as you shift over to the right, top right, worst case scenario, much of Ontario could see as much as a 2 to 3 degrees Celsius increase in temperature by the middle of the century. And, we're not going to talk about the end of the century there, but you can see the big changes in the worst case scenario by the end of the century. Also, hot days. What are we in store for future hot days? That's critical, of course, growing season projections. So focusing on the top left there image, RCP 2.6 best case scenario, still by 2031 to 2050, still looking at additional anywhere from 5 to as much as 20-day increase in the number of hot days annually across southern Ontario and also northwestern Ontario. And then jumping over to the third panel there on the top, RCP 8.5, the worst case scenario where emissions just continue to increase, without any slowing it down. You see much of southern Ontario an increase of 10 to 20, even a little bit more than that in the far south. Number of days, so temperature above 30 degrees Celsius, less so as you go up to the north. And again, I don't even want to talk about what could happen by the end of the century if the worst case scenario comes to fruition. Again, that's unlikely, and as is the best case scenario, again, we're probably looking at somewhere in between here. Now, in terms of growing season, the length of the growing season, as obviously I showed you, continues to grow since the late 1940s, and that will continue to increase most likely by the middle of the century. Best case scenario in the next 10 to 30 years, another increase in 10 to 20 day, I should say another 10 to 20 day increase in the growing season across southern and parts of northwest Ontario. And then the third panel there, worst case scenario, does not look too much different until the worst case scenario by mid-century, but by the end of the century, you can see it really jumps up there. Future summer precipitation scenarios. Best case scenario, next 10 to 30 years or so. Kind of a mixed bag across southern Ontario, eastern Ontario. A little bit drier, a little bit wetter. Really not much to grab onto with that. Of course, much of Canada is expected to see a slight increase in precipitation by the middle part of the century in the best case scenario. And then the worst case scenario on the top right, we see a drying trend across southern, eastern, and parts of northwest Ontario by the middle of the century if greenhouse gas emissions continue to further increase, and still slightly wetter farther to the north. So warming impact on precipitation. Warmer air obviously can hold more moisture. Therefore, in a warmer world, the hydrological cycle is expected to become more intense, which we're already seeing, with more intense rainfall events, more flood events, with more rainfall concentrated in extreme events and longer dry spells in between, which is not what farmers want to see, of course, and anyone wants to see it. So that's the worst case thing. So jumping over to El Nino and La Nina, I was asked to talk about this. This year, we're still in a La Nina. La Nina is the abnormal cooling of the surface waters along the equator. You see that blue area along the equator. That's due to changes in wind direction in that region. We also have El Nino, which is the exact opposite, of warming, unusual warming along that region. Both of these have strong impacts on Canada's climate especially Western Canada, and especially during the winter and spring months. So we are in a La Nina, actually in a second back-to-back La Nina. And this is the most recent El Nino, La Nina winter springs that we've seen going back to about 2009. And we've had about 3 El Ninos in recent years and 5 La Ninas. And you can see that we're under one now. We just came off of one in the last year. So La Nina is certainly winning out recently. And the latest sea surface temperature departures globally, I just called up this map where you can see all the blue there across the equator, signifying the below normal temperatures along the equator. Classic El Nino, La Nina signal there. Also note the colder water off the west coast of Canada. What we call that is the cool Pacific Decadal Oscillation, which also can play a role, especially in Western Canada on the climate there. And then what we've been seeing for years now is all this warm water off of Atlantic Canada, abnormally warm water there. That really has not changed too much. And that's certainly having an influence on the climate in Atlantic Canada. Also fueling a lot of big storms off the coast. Warmer water provides more energy to these storms. So typical El Nino impacts, cold season. Again, I'm considering cold seasons in winter into spring. So we're not under El Nino this year, and that's clearly the case. We have not seen this type of pattern. Certainly drier conditions, Ohio Valley, Great Lakes, and warmer out in Western Canada. But typical La Nina impacts in the cold season, we are seeing this type of pattern, certainly in the northwest of U.S., southwestern British Columbia, the first half of the winter, extremely wet, extremely stormy. That was the telltale sign of La Nina. We've had plenty of cold waves coming down from northwest Canada into the prairies, though recently northwestern Canada has been warmer. And then we've certainly seen wetter conditions, more snow throughout parts of the Great Lakes into Ontario and Quebec, and fairly stormier pattern, warm in the southern United States. So what are the probabilities going out forward? This is the latest forecast from the IRI. Blue is La Nina forecast probability, red is El Nino, and then the gray is the kind of in between the neutral. So MAM there on the bottom left, that's March, April, May projections. Still La Nina favored. It's about 60% chance versus 40% chance of neutral conditions and no chance for El Nino. But as you can see, as we get into the summer months, the probability of still having La Nina decreases steadily. And then you can see El Nino chances start to increase as we get towards the end of the year. So most likely what we're looking at is a weakening La Nina through the spring into the summer, and then probably trending towards neutral later in the summer at this point. Obviously, this plays a critical role in the tropical forecast that we will come out with in May. La Nina typically favors a busier Atlantic season, more moisture coming up into the eastern United States, and some of that gets into eastern Canada as well, whereas El Nino favors less tropical activity. So still early to predict what's going to happen next winter. We usually have to wait until summer to get a good idea what the winter will hold out for next winter in terms of El Nino and La Nina, which is, again, they are the strongest signals that we can use when we come up with these seasonal forecasts. If we're in a neutral situation, again, it's quite a challenge to come up with these seasonal forecasts. There really is not much to go by. So that's why we use analytics. And I'll talk about that very shortly. Going back since November 1st, 2021, percent of average precipitation. You can look at Ontario. It's kind of a mixed bag. We've had some areas a little bit drier than normal, other areas a little bit wetter than normal. Nothing really sticks out too dramatic at this point. Certainly in parts of northwest Ontario have been more wetter than drier, but as you get farther to the north, it's drier in those areas. But look at Alberta. Far north, very wet compared to normal. South, much drier. Percent of normal soil moisture, I just called this up, we're running slightly above normal in southern and eastern Ontario, as well as parts of northern Ontario. But again, nothing out of the ordinary there. But that again could play a role certainly as we get later into the spring. So coming up with analog years, we develop analogs to come up with some of these seasonal forecasts. And, if we don't have a La Nina or an El Nino going on, so we have to look elsewhere and try to come up with analogs in addition to looking at climate model data and observed data. So what we do, say for this spring, to come up with these analog years, I look at the weather pattern over the past late fall, this past winter across the northern hemisphere, and try to match it up with what's any other year going back to the 1960s or so, and I'll pick out matches there. I'm looking at the jet stream pattern and whatnot. Then we'll also look at are there other years where there was a back-to-back La Nina, and is it weakening? It's going to be weakening or so. So look for years like that. So come up with some of those. And again, we look for similarities to what's been going on over the past 3, 4, 5 months here in Canada and in the Northern Hemisphere. Trying to find similarities to other years, and what years have the strongest similarities, we'll consider that an analog year. So our top 3 analog years for this coming spring are 2018, number 1, 2012, and 2021, last year, of course. So all 3 of those years were La Nina years, but there are other things that we looked at. Again, the patterns during the winter were fairly similar as well. So that's a couple things that stick out. And again, we look at Pacific Decadal Oscillation, which I brought up a little bit earlier. We'll look at that as well. Water temperatures across the globe, were they similar and whatnot? So several things go into coming up with these analogs. So those are the top three. We actually come up with sometimes like 10 analogs, but really the top 3 are the ones we focus on. And we try not to include analogs before the 1980s because the climate's changing, and some of those analogs just really are pretty useless at this point. So we try to focus on ones in the past 20, 30 years or so. So just for fun, let's look what happened in 2012, 2018, 2021 in terms of precipitation. And again, I focused on May. I tried to get late April through June, but Environment Canada doesn't. They make it difficult to do this stuff. Some of their data is really kooky, and just I have a tough time grabbing. So I kind of focused on May. So May 2012, the red tells you it was much drier than normal in May 2012 across southern eastern Canada. But look at northwest Canada, wetter. It was wetter during that sort of critical time period there. So that's 2012 during the month of May. Temperature-wise, May of 2012 was pretty warm throughout much of Ontario, fairly close to normal across northwestern Ontario. Growing season, percent of average precipitation. This is the entire growing season of 2012. Looks kind of like what's been going on so far this year. Kind of a mixed bag. Fairly close to normal. Nothing really sticks out there in terms of growing season precipitation. But if you go back, actually, look how dry it was in May, and it ends up the growing season ended up actually being close to normal. So that tells you that season started out dry, and it certainly trended a lot wetter the latter part of the growing season. That was indeed the case. And percent of average precipitation, this is for 2018. Again, we're looking at more dryness across southern eastern Ontario and then up towards the Lake Superior region during the month. And temperature departures, again, it was a warm month across southern, much of Ontario actually, especially southwestern Ontario, very warm compared to normal, 3 to 4 degrees Celsius above normal, so very warm month. And then percent of average precipitation during the growing season of 2018, again, it trended wetter as we got into the second half of the growing season. So it's still far, we look at a little bit of a theme here. It starts out dry, then trends wetter during the growing season. Well, let's jump over to last year. So this is May precipitation 2021, dry, very dry across southern and eastern Ontario. I'm sure many of you remember that, of course, but also cool. So that tells me we had a lot of high pressure systems coming in from the north and the west, which is typical of last year. Again, was a La Nina year. So we had a lot of these cold highs, Arctic highs coming down. Certainly early in the spring season there, a lot of drier air, but also some colder temperatures as well. But you look at northwestern Ontario, actually, temperatures are actually close to normal, slightly above in a few spots. So averaging out the analogs, at least the analogs from May, and again, we don't base our forecast strictly on analogs. Sometimes we, put very little weight on them, especially if they're all over the place. And it doesn't give you a lot of confidence. But if we average out the three analogs from May, it tells me, okay, drier, especially southern and eastern Ontario, was a common theme, especially the early part of the growing season, and then warmer than normal for 2 out of 3 analogs. 2021 was colder. Okay, after analogs, we look at computer model ensemble forecasts. And this is the NMME. It's basically what it is a model used in the United States, and it combines several models across North America and averages them out for a forecast. So this is a forecast for precipitation anomalies. Red is drier than normal, green is wetter than normal from March, April, May this year. So this is a forecast what the computer models are averaging out. So this is an ensemble of forecasts. And when we do forecasts, we like to use ensembles because they tend not to show extremes, but they tend to be more accurate because you're averaging out a lot of models. So you come up with a central theme here. So there is pretty good guidance showing us that things look wetter across Ontario for this upcoming spring. And this is almost like a telltale La Nina signal here. And you can see in the northwest U.S. and southern BC, wetter, and then again wetter in the Great Lakes region, and then dry across the southern United States. So certainly, all these models are pretty much saying, yeah, La Nina is going to continue to have an influence on the weather pattern here into the spring. So they're saying, yes, it's going to be a little bit wetter than normal, especially across southern Ontario. Now, this is the internationally IMME. So this is taking into account all the international forecast models for rainfall or snowfall from March, April, May. And that looks really similar. Again, this gives us good confidence that, computer models are pretty much on board saying wetter spring for British Columbia, wetter spring around the Great Lakes, Ontario, into parts of Quebec. So we like to see that. Sometimes we have they're all over the place, and that we have to go back to the drawing board. So this is a good thing to see, actually. Not that you guys want to have a wet spring, of course, but it helps us in forecasting. Okay, so before I get to the Canada Spring Outlook, this is the AccuWeather U.S. Spring Outlook. This was done by one of our meteorologists, Paul Pastelak, about a month before I did the Canada one. So there are going to be some slight differences because we look at some different things when we draw up these forecasts. And things change, of course, over the course of the month. But his forecast from March through May, at least in the United States, was a continuation of the warmth across the southern portion of the country, cooler conditions across the northwest, and really no real strong signal for temperatures throughout the Great Lakes region. And that's what he was seeing when he drew up this forecast. Precipitation departures, you can see he's going along with the idea of the wetness in the northwest and also throughout the Ohio Valley, Great Lakes, into parts of the northeast idea there. And again, drier conditions across the southern plains. We are dealing with, again, as you guys know, severe drought building back up across California and much of the southwestern U.S. into Texas. Things really improved over the winter, or at least late winter, and especially in California. A lot of snow, which is great news, but complete flip from December to February. They've had very little moisture here over the past 40, 50 days or so from California to the southwest. So things are really drying out very quickly once again there. Paul also does a spring planting outlook for the United States, and he's looking at unfavorable planting conditions across the Ohio Valley. A lot of corn being grown in those areas there, but more as we go to the west. But at least in the Ohio Valley, unfavorable conditions there. Have had a lot of rain, very soggy conditions there. So obviously he's keen on that. I personally think he's a little bit optimistic in Michigan and Missouri. Things are kind of a little bit wetter there. So, but again, he made this up about a month ago. So I think maybe push that green area a little bit farther to the west a bit. And I would probably expand the unfavorable actually a little bit farther north up into Michigan if it was me doing this forecast. But that's what his outlook was about a month ago for planting conditions. And then again, he's going unfavorable in the high plains of the United States. There are very dry conditions really have taken hold in those areas. And then the U.S. spring drought outlook, not good here across the southwest into the high plains. No drought, and I agree with this 100%, across the Great Lakes region into the Ohio Valley. Drier conditions also in the southeast U.S. there. So that's what he's looking at. So I'm pretty good with this map here from what he's showing. Now, this is my forecast for Canada, a spring outlook that I drew up about a week ago. Pretty confident we're looking at below normal temperatures across Western Canada. Still below throughout much of Quebec. As you can see, much of Ontario did not commit to either below or above in southern and eastern Ontario. What I'm looking at here, I think we're going to be dealing with a lot of cloud cover. So that's going to lead to cooler than normal days, but also warmer than normal nights. So you're probably going to end up being close to normal, I suspect, throughout much of Ontario for the spring. But I do think we are looking at above normal temperatures throughout northwestern Ontario and a good chunk of Manitoba. Much drier conditions throughout Manitoba as well. Now, all important precipitation departures, pretty confident with the above in southern BC. I also do feel there'll be a second storm track, more Colorado lows coming up into the Great Lakes. So that's going to yield, again, above normal rainfall throughout much of southern eastern Ontario into southern Quebec. With the increased soil moisture, we've had above normal snowfall in many areas. I do think the risk for flooding is going to be higher than normal in these areas. So again, above normal rainfall for the spring is, I would say I'm a little bit more confident than usual with that for this region. So that's not what we want to hear. Farther north into northern Ontario, I think we're looking at more closer to normal conditions, which is something we like to hear. So spring outlook conclusions for Ontario, generally near normal temperatures, slightly below normal highs versus above normal lows due to higher than average cloud cover. Milder spring for northwestern Ontario, wetter than normal spring, especially for southern eastern Ontario, which may lead to a delay in spring planting, unfortunately, once again. And then the spring flood risk appears to be higher than usual based on current conditions and also our forecast. So that's what we're pretty much looking at this point. And I'll be happy to answer any questions.
Thanks so much, Brett. That was wonderful. Wonderful overview of Canadian and a bit of American and Ontario. That was just great to see what's going to be coming at us for the foreseeable future. I think Mike and Marty and myself all have some questions for you. So
sure.
Yeah, just
unclick my thing here. One second here.
Hey, Brett, Marty here. Hey, that was a great presentation overview of what we can expect for the spring. Also great history and understanding better. I've always heard of, La Nina and La Nina. What I'm wondering is it's always measuring like the temperature of the ocean, but what creates the temperature changes in the ocean? Is it currents coming from Antarctica? Is it lunar cycles? What's actually causing the temperature difference in the Pacific Ocean?
It's changes in the wind, prevailing wind direction. Typically, when we see more easterlies in that region, it piles the warmer water out farther to the west, and you get more upwelling of colder water along the equator, especially off of South America, then out into the Central Pacific. So it's really a change in the prevailing winds. When they become lighter and more up from the east, we typically see a La Nina developing. And then if we get more westerly winds, that pushes the warmer water farther to the east, and therefore you tend to see El Nino. So it's a wind issue pretty much.
Thank you. I've often wondered that why those currents were always changing, but it makes a lot of sense. It's the air currents,
very difficult.
And why sometimes it's in the cycles.
It's in it. Again, the models, computer models, still have a very difficult time predicting if we're going to go into El Nino, La Nina. I would never trust for a computer forecast this early yet for next winter. There's a clear weakness in modeling for that. We usually have to wait until the summer to get a pretty good handle on whether we're going to be looking at La Nina or El Nino conditions or nothing, which is certainly going to be the case the next winter.
Brett, I know when you're looking at your forecasts for a day-to-day or week-to-week, how accurate can you get within a certain amount of days? Like, would you say a week out you're pretty accurate, 3 days out you're pretty accurate? And I'm sure, does it vary? I would think it would vary from southern Ontario to northern Ontario. And how many days would you say I'm really confident about this?
Yeah.
This is still a little iffy.
It depends on the season too. Of course, winter we tend to be more accurate because the jet stream's stronger, everything, the systems are stronger, they're more predictable. Summertime, of course, we deal with thunderstorms, convective precipitation, which is all over the place, and harder to predict. Yeah, you can say there's going to be thunderstorms in a given day, but where they're going to specifically be is very difficult. Certainly a challenge at that point. But our forecasting has certainly increased tremendously 3 to 5 days out. We're very good, over 70% accuracy nowadays. Still getting better, 10 to 14 days out. We still get, have a pretty good idea what the weather pattern can be 10 to 14 days out, general jet stream pattern. You can't really nail the details of that, but you can say with confidence, the jet stream, especially winter forecasting, is going to be in this position. And this is going to be, colder or wetter than normal or drier than normal in a given region. You can, that's been getting better as well. Now, as again, the seasonal forecasting, we're really dependent on signals such as La Nina, El Nino, ocean water temperatures, and again, we try to use the analogs as best we can. But some years there's very little signal. The analogs can be all over the place. If you have a neutral condition in the Pacific, your confidence for the seasonal forecast is going to be low, certainly, no question about it. And we still have to produce those forecasts, but when we put it out, we don't feel too great about it. And we know we have to adjust. If we see something coming up, we will tend to update it. So this year, at least, we're still in a fairly moderate strength La Nina. So our confidence for this spring's forecast, I would say, is probably a little bit higher than normal. That we put out. And, our accuracy usually, again, I'm not saying AccuWeather per se, but most sources for long-range forecasts, you're probably looking at 55%, maybe 60% every year accuracy. So certainly better than a flip of a coin, but there's still room for improvement, of course.
For sure. No, that's wonderful. Thank you.
Yeah.
I just have a quick question for you, Brett, and it's something that I've been thinking about dating back to September. And I remember the discussion around a lot of the extreme storms that we were seeing, thunderstorms here in Ontario. And I remember hearing the word supercell. Can you maybe comment a little bit about that? Because I always remember supercell being storms that we'd hear about through April and May throughout Kansas and Oklahoma. And maybe can you comment a little bit about what happened in September here and extreme events and hail? And I know farmers were concerned of damage to their crops from extreme wind and hail and rain.
Yeah, well, we've had part of the reason we're seeing more of that. Water temperatures in the Gulf of Mexico are continuing to increase. So when you have warmer water, the Gulf of Mexico certainly is a source of moisture for Ontario. And with the increase in water temperatures in the Gulf of Mexico, that is providing an added boost of energy to these storms coming out from the Gulf of Mexico, drawing up even higher dew point air all the way up in Ontario. Dew points are very critical to feeding thunderstorms. And when you have higher than usual dew points that we typically see in, the central plains of the U.S., southern U.S., getting all the way up in Ontario, there's no reason you can't get supercell extreme thunderstorm activity into Ontario. Up in Ontario, typically the jet stream is very critical to the formation of these supercells, and usually in Ontario, the jet streams are typically stronger in Ontario compared to the southern United States. So if you get all that high dew point air, unusually warm air getting as far north up into Ontario, and you already know you're going to have a strong jet stream, there's no reason why you cannot get severe outbreaks of tornado outbreaks, hail outbreaks, all the way up, well up into Ontario. That we've seen that increase in recent years. Again, I think part of that again is the warming, the overall warming trend we're seeing, and again the increased water temperatures that we're seeing in the Gulf of Mexico, feeding these storms that are tracking up towards the Great Lakes, and just providing a much more favorable environment for these powerful storms.
I know, Brett, sometimes the forecasts that farmers listen to, and it's like, oh, I didn't want to hear that. But I got to tell you, on a farmer's perspective, it's really good that we have modern technology that brings us these forecasts so we can kind of plan ahead, at least a couple of days ahead, especially with the spraying operations that occur in the fields, knowing the wind speed. I mean, years ago, when we never had this kind of technology, we could never accomplish what we can today as in agriculture. So we do appreciate everything that meteorologists provide us. Farmers sometimes are meteorologists themselves, always looking at the weather and trying to judge their days and their schedules. But take my hat off to you for the information that you provide us. Thank you.
Yeah, appreciate it. Yeah, it's different every day. I've been doing this for 33 years and still love doing it. Wake up every morning. Every day it's different. The weather is always changing, so it's not the same thing every day. We have another big storm coming up. Obviously tomorrow, or late tonight into tomorrow coming up. And this is it's not so much a super strong storm, but it's a very large storm coming up from the central U.S. up into eastern Canada and northeast U.S. So certainly we're going to have our hands full with that and dealing with rain, snow, ice lines, and all that stuff. So going to be very busy over the next 2 days, no question about it. And we've got some flooding situation again in the Ohio Valley. I really think we're looking at a bad spring. Parts of the Ohio Valley in terms of flooding. Really concerned about that.
That reminds me of things people tell me about, in the olden days, we had snow that was up to the hydro lines, and we did have some big snowstorms like in 78, and there's some periods of ice storms that hit southwestern Ontario, but we don't seem to see it now. Is that just the warming temperatures, or is there any other climatic changes? We did have a big ice storm in the Ottawa Valley area and into Quebec back in, trying to think what year that was, 2004, 8, somewhere in there. But, it's just very occasionally that those happen. But you always hear people say, oh, back in the day, we had those really bad winter storms, but it doesn't seem that bad.
Yeah, I mean, out here, at least in Pennsylvania, I've been living obviously out here 30 years, so we hardly ever get any big snowstorms out here anymore. And I think part of that is just due to warming in general. Most of the bigger storms that we're seeing are trending more towards the coast instead of going inland, because the water is getting warmer off the East Coast. So we're seeing the strongest baroclinic zones, which is where the coldest air clashes with the warmest air, and that's being shifted over towards the ocean. So what I think I've seen over the past 20 or 30 years is most of the big storms forming more off the coast instead of going inland. So that, at least for where I am located, means most of the big snowstorms have been in areas that don't typically see a lot of snow, places such as Philadelphia, New York, Boston. They're getting these big storms. Not a lot of small storms, but big storms, maybe 2 a year or so. But we're not seeing the big storms farther inland, including up into Ontario and parts of Quebec, because the real big storms are shifting more towards the coast, leaving these areas with, smaller, weaker storms in general. So snowfall certainly, at least in where I'm from here, has definitely been trending downward just due to a lack of big storms. That's what I've noticed. Again, we still get a lot of days with snowfall, but it doesn't amount to much. Lake effect snow is also critical in Ontario. The lakes continue to be running warmer than normal, but we're not seeing as many cold outbreaks in recent years. So you need the cold in order to get the lake effect snow. So we're seeing less of that, certainly across the Great Lakes. Not every year, though, but the trend is certainly for less lake effect snow just due to less cold coming down from the north and west. So that's what we're seeing.
The wind's got to be in the right direction. I remember Buffalo just getting dumped on, when the winds come down, Lake Erie. Yeah.
Mm-hmm. Yeah, wind direction is very critical, of course. And one thing I also noticed is the lake effect snow season has, usually peaks December or January, and then it kind of winds down as ice builds up, especially like Erie later in the season. We're seeing the lake effect snow season actually being prolonged, shifted farther back, because we haven't seen a lot of cold Decembers in recent years. So lake effect season seems to be peaking instead of December to January. It's more like January to February, and we're shifting forward because we're not seeing the ice up a lot of these lakes as much as it used to be. So that means more open water later into the season, but also later start to the lake effect snow season. So that's one change we're also thinking.
Well, Brett, on behalf of GFO, we really do appreciate the time you've taken with us today to give us this forecast. Farmers do count on the forecast and help schedule their days, so we all greatly appreciate it from Grain Farmers of Ontario. So thank you for your time.
Not a problem. It's a pleasure to talk to you guys.